Welcome to this tutorial on decision trees for classification. In this video, we'll explore what decision trees are, how they work, and how to implement them in Java step by step. Let's get started. First, let's define what a decision tree is. A decision tree is a flowchart-like structure used for classification and regression tasks. It splits the data into subsets based on feature values, leading to a decision at the leaf nodes. In a decision tree, each internal node represents a feature or attribute, each branch represents a decision rule, and each leaf node represents an outcome or label. The paths from the root to the leaves represent classification rules. Before we dive into coding, let's briefly discuss the key concepts associated with decision trees, such as entropy, information gain, and how to avoid overfitting. Entropy measures the impurity of a dataset. The more mixed the classes in a subset, the higher the entropy. Mathematically, it's defined as follows. Next is information gain, which is used to decide which feature to split on at each node. It's calculated as the difference between the entropy of the dataset before the split and the weighted sum of the entropies after the split. One problem with decision trees is overfitting. A tree that is too deep may capture noise in the data rather than the actual patterns. To mitigate this, we can use techniques such as pruning, which removes branches that have little importance. To illustrate a decision tree, let's use a simple dataset for binary classification. For our example, we will use a dataset with attributes such as age, salary, and the target label buys. Here's how the dataset looks. First, we need to load this dataset in our Java application. We can do this by reading from a CSV file. Below is how you can read the dataset. Once we have the dataset loaded, we want to separate the features from the labels. We can do this with a helper method. With the dataset ready, we can now start building our decision tree. We will create a class called Decision Tree Node, which will represent each node in the tree. It will store the value of the feature, the child nodes, and whether it is a leaf node. Now, we need a recursive function to build the decision tree. This function will check if all labels are the same, select the best feature to split on, and recursively build a tree for the resulting subsets. This is quite a long function, so let's break it down. The method allSame checks if all labels are the same. The method selectBestFeature identifies the feature that offers the highest information gain. And SplitByFeature will partition the dataset based on the selected best feature. The next thing we need is a way to make predictions with our tree. We will add a method in our decision tree class that traverses the tree based on the feature values of an input instance. Now that we have the capability of making predictions, we should also implement a small method to evaluate our decision tree model using metrics like accuracy or confusion matrix. This can be done with a simple evaluation framework. With the predictive capability and evaluation in place, we can now tie everything together in a main method. We will load our dataset, create a decision tree, and make predictions on a test set. In this tutorial, we have built a decision tree for classification from scratch in Java. We covered key concepts such as entropy, information gain, and how to handle overfitting. We now have a functioning decision tree that can make predictions based on input data. Thank you for watching. If you found this tutorial helpful, please give it a thumbs up, subscribe for more content, and let us know in the comments what you'd like to learn next.